So, hello everyone. My name is Animesh Mishra, and I have my colleague Abhishek Yadvanshi with me. And today, I'm excited to present our project Aroya Setu, a comprehensive health surveillance platform, which was designed specifically for the northeastern region of India. Now, the problem statement was कि northeastern government को problem हो रहा था उनके rural villages पे water बॉर्न डिसीजेस का जो आउटब्रेक है उसको रोकने की वजह से और वहां पर जो डेथ्स हो रही है उनको रोकने की वजह से जिसमें कि कई ज्यादा कंसर्न अथॉरिटीज भी थी बट देयर वाज नो सिस्टम व्हिच वाज लिंकिंग देम ऑल टुगेदर so in the monsoon season mostly it was very difficult to do it so we made a system which makes sure it is all connected and we have also used AI to monitor and also the rapid alert system which presents real-time health reporting across the entire region. So let us have a look how it works. Now, this is our backend directory, which is having admin dashboard and prediction, and there are a lot of folders over here. Where admin dashboard and everything else, this basically makes for scalable architecture. We are using microservices. We have also been using Celery for asynchronous task scheduling, and we will be using Redis as a broker there. So the backend, which you can see, is powered by Django REST framework. It's the engine of our platform. It will handle the data from all over the sources, and it is also managing our PostgreSQL database, which is deployed onto the Supabase client, right? And it is also running our models. By the way, there are two models which are working over here, which are rule-based model, which is a small level model, and a high-level model, which will be our local LLM, which is deployed on Olama, and the name of that model is Gemma 1 billion parameter. So now, continuing to my front-end directory, let us have a look at that too. So, in front-end, we will be using React, TypeScript, and White, and we have also used SIH25001 UI library for our componenting, and also Tailwind CSS for some styling, because we had very role-specific dashboards. So now, let us have a look at our monitoring system, which comes with two-tier prediction system. First of which is a role-based prediction model, which basically gives the alert inside the dashboards only, the dashboards of three concerned communities, which are ASHA workers, NGO workers, and also the clinical workers. So now these are some rules defined, which we have already defined inside our model. Now these rules will work in such a way that they will generate the small kind of alert. Now this alert will be in a kind of summary, and then this summary will be gone through our high level model, and then this high level model through the API will get this summary onto some another model, and this another model then we'll give it back to the admin dashboard, which will show the entire prediction in natural language format with the risk percentage. Now let us talk about the second high level model we are having. This is the Olama model that I was talking about. Once the rule-based alert is created, it triggers our more advanced model. So this model performs a deeper analysis. We will have a look at its formulas later because we have used formula-based prediction because it can be very accurate, and we have thought of a way to improve it for further edu so that we can improve our responsiveness even better. And for the summary generation, we have been predetermining how to make the summary and context directive very proper, maintaining a proper HTML structure and monitoring it so that the AI does not hallucinate and also follows the similar model. So let us switch back to the application screen and let us see the platform in action. Now, we are having these three login buttons where you can also register as ASHA worker, select your state. There will be no such thing as state there because it will all only be for northeastern states. So you can also register as different members where there will be NGOs and there will be clinics. So there is dashboard for all three. And as I also told you, this is a multilingual application which will work in 4 different applications. We have been using React Edit. Okay, and we have we have deployed the multilinguality using an II-A10 library, which will be taking all the stuff from a translation.json file and then uses it on the templates that we have directed on each of our use states. Now, let us talk about each of the directives. First of all, we will go to one of the dashboards. Let us say we are going to ASHA dashboard. So the ASHA workers are the play a major role in data collection, and also because ASHA workers will work in such a way that they will collect all the information about the patient from door to door. And now you will ask ki, how will they collect the information? Uske liye we have thought ki we will provide them with our manual water testing kit, and वो लोग just घरों पर जाकर they will take water in any way and then test it to get the village water quality in basic sense. In the layman terms, this is it. So now you'll ask me, how will they submit the report? So this report will be submitted by them, and there will be also a mobile application which will have the same interface as this website. And this mobile application will store all the information in local cache storage, so that even if in the remote villages where there is no mobile network, whenever they will try to send the report, even if they are not having the cellular network at that point, whenever they will have it, the report will be submitted at that point. So you can select the symptoms, select the severity of the particular disease that they are having. You can select the water sources they are having, and then you can describe the treatment, as the ASHA workers are one of the few people who are having some sort of medical expertise. So also they can sell the water contamination alert, and this is alert generated by our bigger model, and this will be transmitted to them through our admin dashboard. So that's all for ASHA workers. Now the another people who will be collecting data are admin dashboard, not the admin dashboard, NGO dashboard. Now the NGO dashboard works in such a way that they will also collect the data, but the data collection will be in different format. Actually, they will collect data from multiple villages, and these multiple villages will also have our water testing usage. Now, because the NGO villages will also get our manual water testing kit, and they will just use that water testing kit, they will just dip our kit inside the main source of the water in villages. So they can add this kind of data from either the waste disposal system is available or not, flooding or waterlogging issues are not there, typhoid cases, fever cases, diarrhea cases, because as of now in the monsoon season, these are the most common diseases that are there. But as soon as we get the data sets, we will try to make it even more diverse. So as of now, these are the monthly reports and all the other reports. Now there is one more thing remaining, and these people are clinic workers. Now clinic workers are very important because they will show how many symptoms were there, the correct symptoms, and they will also show how many people are dead. So the deaths recorded are also told by these people only. They will also get these health alerts, and the recent activities will also be shown by them, whatever they have submitted. The water contamination alert sent by admin will also be shown. The weekly report submitted by them will also be shown. Whatever submit report that they do, that will be shown here. Now this monthly and weekly report will be shown by them. Like this month, there were 10 cases. The diseases why they done was this, and that's all. Because basically the main heart of this thing is the admin dashboard, which works in very peculiar way. It aggregates data from various sources, and let me just show you how the data sources work. So this is our admin village schema, which takes the cases, the total cases from all of the dashboards, NGO, clinic, and also the ASHA worker. The hospitalized cases and total deaths from their risk level. The risk level will be generated by our model. The risk percentage will also be generated by our model. The fever, cholera, typhoid, these things will be generated by our various dashboards only, because we have aggregated it. What we thought of is, instead of joining all the APIs and then sending it to our front end, why don't we make an entire different table which will aggregate it before and then send it to our front end in a single API. So in this way, the entire process became way faster and it completed in milliseconds. So this is how we did it. Now, let me show you how it works in action, because it looks seriously beautiful. Now, let us go on to the admin website and take a look. So this is our admin website now. There are many things that you can see here. Let us understand them one by one. First of all, you will ask कि भाई इतना ज़्यादा सिवियर केसेस क्यों दिख रहा है, क्योंकि हम लोगों का जो स्कोर वेट था सिविरिटी स्कोर का वो काफ़ी ज़्यादा था, और इसका एक असर ये था कि इसकी वजह से थोड़ा रिस्क स्कोर कैलकुलेशन में प्रॉब्लम हो गया, क्योंकि हम लोगों ने उसको 20 रख दिया था. माने 20 से ऊपर जिसमें भी प्रॉब्लम आएगा, जिस भी विलेजेस में 20 से ज़्यादा लोगों को डिसीजेज होगी, इट विल जस्ट शो सिवियर. So we can see this is our interactive map, and this whole all of our application things are dynamic. So if we click on any of these things, let us say we click on this village. So this is Churachandpur and this is in Manipur, and the cases are 47. So the cases are mild and moderate and low. You can see all the cases, and for each one you can see all the cases. Like if there is high risk villages and moderate risk villages, you can see them all. And whatever the population, whatever the cases they have gotten, deaths, hospitalized people, and also the additional info and each of the cases by their symptom distributed through a graph, so that the person who is using it will be easily able to grasp the condition of that particular villages. Now, let us just keep looking on some of the villages so you get an idea how the monthly trends and everything and is falling together. Also, these live alerts will be generated by all the dashboards, and this is how our model is working. This is our AI power chat prediction, which, as I said, is given by Gemma model. So as of now, we have just added 4. And now one more thing, these alerts will be added through Celery in the background, so that it does not give the API request again and again. Like once in a while, in every 24 hours, they will be generating as much as alert summaries, as much as alerts are given by each of the dashboards. This is how the alerts will look. They will all have a risk overview and the key findings and immediate actions required, the NGOs escalation protocol, and the monitoring guidance. Each one will have this information only. We have made sure to pre-process all the data that is coming onto this dashboard, so it is always correct and predictive. So now we can also take a look at how the stuff under the hood is working. So I will try to explain. Basically हम लोगों ने क्या करा है, डैशबोर्ड पर डेटा दिखाने के लिए अलग अलग हेल्थ रिपोर्ट्स से और अलग अलग क्लिनिक रिपोर्ट्स से, इन सारी टेबल्स से डेटा लिया है. सिम्टम काउंटर जो हमारा है, जो हमारी सिम्टम की काउंटिंग कर रहा है, जैसे कि फीवर, डायरिया या वॉमिटिंग, यहाँ पर ये डेटा सिम्टम चार्ट्स में शो हो रहा था. अब ये डेटा हर जगह से आ रहा है. सेवरिटी काउंटिंग में माइल्ड है कि सीवियर है, इसमें केसेस की गिनती करी जाती है. टोटल केसेस में आप ये दिखाते हैं कि टोटल केस क्या है, पर्टिकुलर जितने भी हेल्थ रिपोर्ट हैं, जितने भी क्लिनिक रिपोर्ट है मेरी स्कीमा में, इन सबको ऐड करके निकलते हैं. जो रिस्क स्कोर कैलकुलेशन है, उसके लिए हम लोगों ने एक फॉर्मूला लगाया था, जो कि इट वाज बेसिकली a very long formula, 0.6 multiplied by severity score plus 0.3 into case score plus water penalty and untreated penalty, जिसको मैं समझाने की कोशिश करूंगा in layman terms so you can get away कि severity score का 60% weight रहेगा. severity score मतलब cases कितने serious है. ये काम ऐसे करेगा कि हम लोगों ने severity cases में जो severe cases हैं उनको 3x दिया था, moderate को 2x और mild को 1x. दिस वजह से we multiplied it by 0.6 and the weight is 60%. इससे एक नॉर्मलाइज्ड स्कोर बन जाएगा. जो केस स्कोर है वो 30% वेट कैरी करेगा, और विलेज में जितने भी केसेस होंगे उस पर बेस्ड एक केस स्कोर होगा. प्रॉब्लम इसमें यह थी कि यहाँ पर हमारा थ्रेशोल्ड 20 केसेस का ही था. इसका मतलब अगर 20 से ज्यादा केसेस होते हैं तो ये जो स्कोर है वो अपने आप 100 हो जाएगा, क्योंकि ये मिनिमम निकालता है 100 का और टोटल केसेस को डिवाइड बाय 20 into 100 का. सो वाटर पेनल्टी वाज आल्सो अ थिंग हियर, जिसमें साफ पानी ना होने पर हम लोग एक पेनल्टी लगा रहे थे इन अवर फॉर्मूला, कि अगर एनजीओ सर्वे में जो कि क्लीन ड्रिंकिंग वाटर की हमारी प्रॉपर्टी है, तो वो क्लीन ड्रिंकिंग वाटर प्रॉपर्टी अगर है या फॉल्स है तो उसमें फाइनल स्कोर में सीधे 30 पॉइंट जुड़ जाते हैं. अब जो फाइनल स्कोर था विच वाज अराउंड 39, तो इससे हमारा फाइनल रिस्क बेसिस ऐसा बनता था कि इफ इट इज ग्रेटर देन 90 then the risk score is very high. If it is greater than 60, the risk score is high. If it is more than 40, then it is moderate, and if it is more than 20, then it is low, and then it is less lower than less, which is but good. So prediction के लिए हम लोग यही फॉर्मूला यूज करें. द सिविरिटी डिस्ट्रीब्यूशन जो कि पाई चार्ट में आपको दिख रहा था, उसमें वही मॉडरेट और माइल्ड और सीवियर की गिनती हो रही थी, इसको परसेंटेज में कन्वर्ट किया गया. So I think this much is enough for me to give you overview about the entire website. I hope you understood how it works on the core. अभी हमारा जो data collection है, it is the core and heart of this website. So my two colleagues also worked in this program, in which one of them is here. They've also prepared a research paper which is currently published under the DMEB publication about water monitoring only. So now I will give Abhishek Yaduvanshi chance. He will explain how the kit provided to each of these workers will work. Abhishek.
Okay, so this is our kit. Actually, this kit will be provided with the 3 water quality sensor, which is the TDS, turbidity and PS sensor, but as of now we have only the turbidity sensor, so we will keep testing with this only. So for the testing we have a 2 quality of water, one is good quality and poor quality of water. So now this is our good quality of water, and you can see the green LED is blinking, so it signifies the good quality of water. And you can see on the ASHA worker dashboard. Animus, please open the ASHA worker dashboard.
Wait a minute, Abhishek, I'll do it. Okay, so this entire thing is dynamic, so to say. This is our live turbidity reading, and when Abhishek will do the work there, it will show it here.
Okay, so yes, now you can see that this is a good quality of water. If I change, and this is our poor quality of water, and when we dip in the sensor in this, so you can see the red LED is blinking, which signifies the poor quality, and you can see on the dashboard also. Now I will tell you how the thing is work. Now this is our turbidity sensor, so this measures the quality of water based on the transparency, and actually I'll show you. This is our hardware part. So this is our Arduino. This collect the data from the turbidity, and this module send the data from to this ESP8226. This is our Wi-Fi module, and this sends the data to our directly to our database, which is the Postgres. And जो हमारी वेबसाइट है वो डायनामिक, तो वो डायरेक्टली डेटा एक्सेस करती है डेटाबेस से एंड शोज द रियल टाइम डेटा. एंड एक्चुअली हम इस पूरी किट को एक लाइक दिस ग्लास ऑफ साइज में कंप्रेस कर देंगे, और इस किट को प्रोवाइड करेंगे आशा वर्कर को. एंड जब भी आशा वर्कर डोर टू डोर जाएंगे पेशेंट्स की हेल्थ कंडीशन चेक करने के लिए, तो उनसे उनका जो भी पानी वो ड्रिंकिंग वाटर है उनसे मांगेंगे, और हमारे जो किट है उससे रियल टाइम पे चेक करेंगे. अब ये इससे वो खुद भी और रियल टाइम पे डेटा देख पाएंगे जो बेस्ड ऑन द लाइट्स, एंड जो पेशेंट्स को वार्न भी कर देंगे, और जो इसका एक्चुअल रीडिंग है वो हमारे डेटाबेस टेबल में जा रहा है, तो वहाँ से जो डैशबोर्ड पे एक्चुअल रीडिंग आ रही है उसके बेस पे हम उस डेटा का यूज़ करके वो प्रेडिक्शन कर देंगे. सो दिस इज़ ऑल अबाउट आवर किट. नाउ अनिमेश, प्लीज़ कंटिन्यू.
So thanks Abhishek for telling it, for dialing in. So I just wanted to tell you guys how excited we are for this project, and our goal with the project is to create a unified intelligent system that connects every healthcare stakeholder. Now, from ASHA workers on the ground to ministry officials at the top of it, from bottom to top level approach, our platform will ensure that the critical health data is analyzed and acted upon in real time to prevent and manage the waterborne disease outbreaks. And this is how I'm taking my leave. Thank you.